Probability theory is the mathematical theory of likelihood. In real-world situations, the outcomes of certain trials or experiments are often uncertain. For example, if you flip a coin, it's uncertain as to whether it will land heads or tails. Or if two teams play a football match, the outcome is usually uncertain. In situations like this, often we want to estimate the likelihood of various different outcomes, and probability theory is the mathematical theory that allows us to do that. In this lesson, we're going to talk about the likelihood scale, which is an informal way of talking about likelihoods of events without having to use numbers. In later lessons, we'll get into the numerical or quantitative side of probability theory, but for the moment we'll just talk about likelihoods. Let's look at some events and their likelihoods. So here are 5 different possible events with different likelihoods associated to them. So let's go through them one by one. Event A, the sun will rise tomorrow. I think most people agree that that event is a certainty. What about B? I roll a standard 6-sided die, shown in the picture here, and get 7. Well, again, I think that most people will agree that that's impossible. Event C, I flip a coin and get heads. So a standard coin has 2 sides showing heads and tails. And to get heads when you flip the coin, well, it seems that that should be about as likely as it is unlikely. Or we'd often say that the likelihood is evens, or it's 50-50. Event D, it will snow at Dublin Airport next year on December 25th. Well, certainly that's a possibility, but history would indicate that while it is possible and does happen occasionally, that it is unlikely. And finally, event E, it will rain somewhere in Ireland next year on December 25th. Well, again, it's certainly possible that that will not occur. However, given that Ireland has a fairly wet climate during the winter, it's safe to say that it's likely that it will rain somewhere next year on December 25th in Ireland. So we've gone through these 5 events and we've assigned verbal descriptions of the likelihood to each of them. We can think of these likelihood descriptions as being laid out along a scale. So here's my scale, and at one end I'll put impossible. So events that are impossible would lie at this end of the scale. And at the other end we'll put events that are certain. And in the middle of the scale, we'll put evens. So events in the middle of the scale are as likely as they are unlikely. So let's see where our events A, B, C, D, and E lie on this scale. Well, we say that A is certain, so we'd put A at this end here. B, rolling a 7 on a standard 6-sided die, well, that's impossible, so that goes at this end. Event C, flipping a coin and getting heads, we said that was evens, so we'll put it in the middle here. And what about D, the event of snowing at Dublin Airport next Christmas Day? Well, that's not impossible, but it is unlikely, so it might go somewhere in here on our scale. And event E, the event of raining somewhere in Ireland next year on December 25th, well, that's not certain, but it is very likely. So we put it somewhere here. So the events in between impossible and evens, we would call those unlikely. And events in between evens and certain, we would call likely. So this is what we call the likelihood scale. It's an informal way of classifying the likelihood of various different events. From a mathematical point of view, however, this way of talking about likelihoods is not very satisfactory. We'd like to be able to be more precise than a scale like this allows. For example, suppose that you want to pick a player to take penalties for your soccer team. If we're thinking about professional soccer players, for example, It's safe to say that all professional soccer players are likely to score a penalty. However, some players are more likely than others. And if you're the coach of a soccer team, being able to say exactly who is the most likely is an important piece of information to have. In later lessons, we'll see how probability theory allows us to be a bit more precise than this likelihood scale allows.